Hello students, in today's session we shall discuss the remaining questions of the atomic structure. And that the first question is, if the Planck's constant H equals to 6.6 into 10 power minus 34 joule seconds, the de Broglie's wavelength of a particle having momentum of 3.3 into 10 power minus 24 kg meter per second will be. So, let's take the de Broglie's wavelength of the particle has to be calculated. So that let us take the lambda equals to h by mv. Planck's constant value is given 6.6 into 10 power minus 34 joule seconds, and mass of the particle, directly momentum is given. So in the place of mv we can write down the momentum p. Its value is 3.3 into 10 power minus 24 kg meter per second. So if you solve this, you will get the 2 into 10 power minus 10 meters, that is equals to 2 angstroms. Why? Because 1 angstrom equals to 10 power minus 10 meters. So option D is correct. Let's solve the question number 2. The uncertainty in the momentum of an electron is 1.0 in 10 power minus 5 kg meter per second. The uncertainty in its position will be, Planck's constant value is given. So this is according to Heisenberg's uncertainty principle. Delta x equals to, we can write it as a h divided by 4 pi into delta p. So let's substitute the remaining this information given in the question. H value is given as 6.63 in 10 power minus 34 joule seconds, and this is 4. Pi value is 3.14, and delta p, uncertainty momentum, is given as 10 power minus 5. So by solving this, we shall get the 5.27 into 10 power minus 30 meters. So option C is correct. Let us solve the question number 3. The uncertainty in position and velocity of a particle are 10 power minus 10 meter and 5.27 in 10 power minus 24 meter per second respectively. Calculate the mass of the particle. Planck's constant value is given. So we know that according to the Heisenberg's uncertainty principle, delta x into m delta v is equals to h divided by 4 pi. So here we need to calculate the mass of the particle. So directly m is equals to h divided by 4 pi delta x into delta v. So let's try to substitute the given information here, that is 6.625 into 10 power minus 34 divided by 4 into 3.14 into delta x value is 10 power minus 10 into, and the remaining delta uncertain velocity is 5.27 into 10 power minus 24. So just solve this one, we shall get the 0.099 kg. So option A is correct for this. Let's solve the question number 4. The wave mechanical model of an atom is based upon de Broglie's concept. It says the dual character of the matter means both particle as well as the wave nature. Heisenberg uncertainty principle also says indirectly about the wave nature. That is the reason why we can find out the probability of finding electron around the equation, around the nucleus. Schrodinger's wave equation is directly about the wave function of the electron. So all these theories, they basically explains about the wave mechanical model of the atom. So option D is correct for this. And fifth one is, electron density in an orbital is correctly described by. So the correct representation is described by directly psi square. Let us solve the question number 6 now. The question is, the maximum number of atomic orbitals associated with a principal quantum number 5 is. So the number of orbitals in a shell can be calculated by using the formula n square, where n stands for the principal quantum number. So here n value is given as 5. Therefore 5 square, that means it is equals to the 25. So option D is correct. Let us solve the question number 7. Beryllium's fourth electron will have the 4 quantum numbers. Let us write down the beryllium atomic number and electronic configuration. 4 and electronic configuration is 1s2, 2s2. So this 2s orbital is having the 2 electrons. In that last electron they are asking. So let's try to solve that. See, this particular number of the shell says about the n value. So n equals to 2, and for s orbital L equals to 0, and in this s orbital 2 electrons are there. One is upward direction, second one is the downward direction. Okay. So the second electron usually we represent like this. We can take it as a plus of or minus of, that is different category. So let us take the even spin quantum number. Spin quantum number you can write down the plus half or minus half. Any combination can be written. And magnetic quantum number value is, we know that 2L plus 1. So here 2 into L value is 0 plus 1, that equals to 1. So generally don't think that M value is always 1. This M value starts from the minus L to 0 to ends with the plus L value. So L value is only 0. So that one value of M value is equals to 0. So finally 4 quantum numbers are here. We can write N equals to 2, L equals to 0, M equals to 0, and S may be either plus half or minus half. Let us see here. N equals to 2, 2. So these maybe both are correct. But here L equals to 0, this is about the s orbital. L equals to 1 means this is about the p orbital. And M equals to 0 and S equals to, you can take either minus half or plus half for a particular electron in a particular orbital. So option C is correct. Question number 8. For a given value of n principal quantum number, the energy of different subshells can be arranged in the order of. So for any particular orbital, F orbital energy is more than the D orbital, which is more than the P orbital, which is more than the S orbital, because S orbital is close to the nucleus. Next P orbital comes, next D orbital comes, next F orbital comes. When you go away from the nucleus, the energy of the orbit and orbital both increases. So that option A is correct. 9th question. Correct a set of 4 quantum numbers for the outermost electron of the rubidium. Atomic number is 37. So let's write down the 9th question answer. We know that first group elements hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So for first element it is always 1s1 configuration, last electronic configuration I am writing. For lithium it will be 2s1, sodium it will be 3s1, potassium 4s1, rubidium 5s1, cesium 6s1 and francium 7s1. So rubidium we have to select. So that is 5s1 configuration. In that this value number says that principal quantum number n equals to 5. And S value for L value for the S orbital is equals to 0, and magnetic quantum number is also equals to 0. And this value, one electron, it may have the either plus half configuration orientation or minus half orientation. So these are the possible values for the 5s1 configuration. Now let us check. So here 5 is there. In first 3 options 5 are there, but second option here is 1, here 1, that says about the p orbital, and here 0 is there, and here also it is 0, it is half. So that option A is correct. So let us solve the question number 10 here. The order of increasing energies of the orbitals follows. So generally we have to follow the n plus L value to find out the energy of the orbitals. Here in all these 4 options only these 5 combination of orbitals are given. I will write down those 5 combination of orbitals: 3s, 3p, 3d, 4s, 4p. Let's write down the n value and L value and n plus L value. So n value is, this is always starting number is n value, and this is about the L value. For s orbital, L equals to 0 and L equals to 1 means that is p orbital, and L equals to 2 means d orbital, L equals to 3 means f orbital. So here it is n value 3, s value 0, n plus L value is 3, and n value 3, L value 1, so it is equals to 4. This is 3, 2, 5. This is 4, 0, 4. This is 4, 1, 5. Now the points to be remembered to find out the higher energy orbital is, higher the n plus L value, more will be the energy of the orbital. If any two orbitals are having same n plus L value, in such cases, the orbital with lower n value will be considered as lower energy orbital. So according to the Aufbau principle, electrons first enter into the lower energy orbital, then they enter into the higher energy orbital only after completely filling of the lower energy orbital. So let us see here, n value is lowest, n plus L value is lowest for 3s orbital, so 3s comes first. Next, there are two orbitals which are having the same n plus L value, 3p and 4s, but in this 3p, n value is less, but 4s n value is more, so that this is considered the lower energy orbital. So next electrons goes to the 3p orbital, and next immediately it goes to the 4s orbital, and next there is a competition between the 3d and 4p, but both are having the same n plus L value, but here 3d is having the lower n value, so that electrons preferably enters to the 3d orbital, then enters into the 4p orbital. So this is the order of filling of the electrons into the various orbitals, 3s, 3p, 4s, 3d, 4p. Option A is correct. So question number 11, the total spin resulting from a D7 configuration is, so D7 configuration, if you fill the electrons into the various orbitals, as the D subshell is having the 5 d orbitals, 1, 2, 3, 4, 5. So just fill these electrons here, 1, 2, 3, 4, 5, 6, 7. See, whenever pairing of electrons are there, their spins will be mutually cancelled. So these electrons will not be considered while calculating the total spin. So we have to consider only the unpaired electrons. So here 3 unpaired electrons are there. So 3 into each electron spin is let it be half. So it is equals to 3 and half. Option A is correct. Let's solve the question number 12. Choose the correct statement or options, they said. So these options are, shapes of orbitals are functional, representation of mathematical solution of the Schrodinger's wave equation. They do not represent a picture of electric charge on the matter. So this is correct. And next one is, smaller the wavelength of electron wave, more is the revolving power of the electron. It is also correct. Uncertainty in measurement is not due to the lack of any experimental technique, but due to the nature of subatomic particle itself. It's true. Why? Because the particle, the moment when the light strikes on a particular particle, the particle starts revolving around the nucleus very fast. So that if you want to find out a particular electron around the nucleus, you have to see the electron. So for that purpose, you have to put some light on the electron. So light has to reflect and it has to reach your eye. Then only able to see the electron. Okay. In such cases, when you put the light, electron gains the energy from the light and it starts revolving, so that you cannot point out the electron's position. If you want to point out the electron position, then the electron should not revolve around the nucleus, so that you should not put the light. So according to Heisenberg, it becomes difficult to find out both the position and the speed of the electron simultaneously. So all options are correct. Option D is correct for this question. Let us solve the question number 13. Given the mass of electron is 9.11 into 10 power minus 31 kg, Planck's constant is 6.626 into 10 power minus 34 joule second. The uncertainty involved in the measurement of velocity within the distance of 0.1 angstroms is. So let's try to find out the uncertainty in the velocity. Delta V equals to h divided by 4 pi delta x into m. This is according to Heisenberg's uncertainty principle. So delta V equals to 6.626 into 10 power minus 34 divided by 4 into 3.14 into, and uncertainty in position is given as 0.1 angstroms. So 0.1 into 1 angstrom equals 10 power minus 10 meters, and mass 9.11 into 10 power minus 31. So by solving everything, we shall get the 5.79 into 10 power 6 meter per second. So option D is correct. Now let's solve the question number 14. Calculate the momentum of radiations of wavelength 0.33 nanometer. So we know that de Broglie's equation lambda equals to h by mv, and mv is equals to h divided by lambda. They asked about the calculate the momentum. So this value equals to momentum. So we can write the P here directly. Let's substitute the lambda value and h value here. So it is equals to 6.625 into 10 power minus 34 joule seconds divided by 0.33 nanometers are given. Just convert them into the meters. 10 power minus 9 meters. So if we solve this, we shall get this 2.01 into 10 power minus 24 kg meter per second. So option A is true. Let us solve the question number 15 now. The orbital having m equals to minus 2 should not be present in the following subshell. So we know that s orbital values L equals to 0 s orbital, L equals to 1 p orbital, L equals to 2 d orbital, and so on it continues. And m values always starts from the minus L, 0 plus L. These are the m values for any orbital. So in the case of the s orbital, it is 0, 0, 0. So m value is always 0 only. And for the p orbital, the possible m values for the p subshell are minus 1, 0, plus 1. Because p value for p orbital L value is equals to 1. So m values are always starts from the minus L, 0, plus L. That means here 1 is there, so we have to add on the minus 1, 0, plus 1. In the case of the d orbital, it will be minus 2, minus 1, 0, plus 1, plus 2, and it continues like this. So for p orbital, you cannot write down the values more than or less than these values. It is only ranges from the minus 1 to plus 1. So that here they said m value should be minus 2, which is possible for all these orbitals and not possible for the p orbital. So our question 15th one answer is D. Now let us solve the question number 16. Calculate the wavelength of a moving electron having 4.55 to 10 power minus 25 joules of kinetic energy. So it is, we know that kinetic energy is equals to half mv square. That value equals to, they had given 4.55 into 10 power minus 25 joules. So v square value is equals to 2 into, because it goes there, no, 2 into 4.55 into 10 power minus 25 and divided by mass of the electron is 9.108 into 10 power minus 31 kg. So here this velocity v value we will get the 10 power 3 meters per second. Now we can substitute this one in the lambda equals to h by mv. So here 6.625 into 10 power minus 34 divided by 9.108 into 10 power minus 31 into velocity value just now we have got here 10 power 3. So by solving this, we shall get the 7.27 into 10 power minus 7 meter. So option, here it is minus 7, option B is correct. Alternatively you can use the another formula, same formula, lambda equals to h divided by root of 2m ke. This is the formula. De Broglie's wavelength, you will get h value. This is the mass of the particle. This is the kinetic energy. Directly you can substitute all these values. You will get the lambda value. Let's solve the question number 17. The minimum energy required to overcome the attractive forces between the electron and surface of silver metal is 7.52 in 10 power minus 19 joules. What will be the maximum kinetic energy of electron ejected out from silver, which is being exposed to ultraviolet light of lambda 3.360 angstroms. So according to the photoelectric effect, we know that there is a particular atom whose nucleus is at the center of the atom. Electron is revolving around the nucleus. So when a light of certain frequency or wavelength falls on the electron, this electron absorbs the energy. So out of this amount of energy, the electron will utilize some of the energy to overcome this nucleus attraction power, and afterwards electron will come out of the atom and it will use the remaining energy for its kinetic energy. So simply if you see here, imagine there is a 10 kilojoules of energy is given to the electron, and here 2 kilojoules of energy is required for the electron to overcome the nucleus attraction power. So remaining energy, whatever the difference is there, that will be the kinetic energy of the electron. So this is the procedure. So in this particular question, they did not give the energy directly, but given the this one wavelength of the electron is given, that is 360 angstroms. So let's try to find out the what is the energy of the light that falls on the electron. So let's try to write down the energy value equals to hc by lambda and substitute these values. H value is already given here, that is 6.625 into 10 power minus 27 into 3 into 10 power 10 divided by lambda value 360 into 10 power minus 8. So we shall get the 5.52 into 10 power 11 ergs, and this if you convert into joules, then it will be 5.52 into 10 power minus 18 joules. So therefore the maximum kinetic energy means this much amount of energy falls on the electron. So let's find out the kinetic energy. So kinetic energy is equals to the energy absorbed, and this is the difference. So we get the 7.52 into 10 power minus 19 joules minus 0.552 into 10 power minus 19 joules. Both I have taken the joules only. So kinetic energy of the electron can be known as 6.96 into 10 power minus 19 joules. So option B is correct. Let's solve the question number 18. So in hydrogen atom, an electron is in its normal state absorbs 2 times of the energy as it requires to escape. This is the escaping energy, that is 13.6 electron volts from the atom. The wavelength of the emitted electron will be. So first of all, energy absorbed by the atom is equals to 2 times of the escaping energy, that is 13.6, total is equals to 27.2 electron volt, and energy consumed is equals to 13.6 electron volt. This much amount of energy it consumed. Absorbed this much, consumed this much, and difference of energy is always is equals to kinetic energy. So that is equals to 13.6 electron volt, because difference is 13.6 only. 27.2 minus 13.6, you get the 13.6. You just convert this value into the joules, that is multiply with 1.6 into 10 power minus 19 joules. So just find out the velocity, that is equals to root 2 KEM, means half mv square is equals to kinetic energy equals to half mv square. You can use this formula and find out the velocity. This is one procedure. Or else, since we got the directly kinetic energy, we can calculate the lambda value, that is lambda equals to h divided by root over 2m ke. So h value is equals to 6.63 into 10 power minus 34 joules seconds, and the root over 2 into mass of the electron is 9.1 into 10 power minus 31 kg, and the kinetic energy of the electron just now we calculated in the joules, that is 13.6 into 1.6 into 10 power minus 19 joules. So by solving all these, we shall get the lambda value is 3.46 into 10 power minus 10 meters. So option C is correct. Let's solve the question number 19. The wavelength of a 150 grams rubber ball moving with a velocity 50 meters per second is. So according to the means mass of the rubber ball is given, and velocity also given. They are asking the wavelength, means just like a de Broglie's wave equation, lambda equals to h by m into v. So velocity is given. So here velocity is given 50 meters per second. So that you can convert, because here if you want to take the mass in grams, you have to convert them into the centimeters per second. That is equals to 50 into 10 power 2 centimeters per second. Or else you can convert the grams into the kg. But here answers are in the centimeters, no? So that I am converting this one into the centimeters only directly. So lambda equals to h value, Planck's constant value 6.625 into 10 power minus 27 arc seconds divided by 150 grams into 50 into 10 power 2 centimeters per second, that is equals to 8.83 into 10 power minus 33 centimeters. So option B is correct. Students, hope you like this video. Like and share this video. Subscribe the channel. Thank you.